Hello everyone. In this set of videos, we are going to start talking about differential equations. So a differential equation is an equation that has derivatives in it. The goal is to figure out what is the original function. So we're going to start with some baby steps. We're going to start by verifying solutions to differential equations. So let's say that we have this function and we are claiming this guy is the solution or a solution to this differential equation. Could we verify it? Could we check it? So to check it, we have to plug in everything that we have. So we have a function for y that we're going to plug in for y. And then we're going to take the derivative of this so that we can plug that in for the y prime. So if I were to take the derivative of e to the u is e to the u times the derivative of the exponent. So my function y equals e to the negative 3x plus 2x plus 3 has a derivative of minus 3e to the 3x plus 2. And then we're going to substitute in all of our pieces, and we're going to see if we get a true statement. I substitute in my y prime plus 3 times y. I want to know, is that equals? I'm going to put a question over the equals. 6 times x plus 11. So let's do some fancy math to simplify that left-hand side. I'm going to distribute that 3. You can see how those e to the 3x terms are going to cancel. And I'm going to get 6 times x plus 11 on the left, and that is definitely equal to 6 times x plus 11 on the right. So we would say, yes, this is a solution to the differential equation, and I'm going to abbreviate that dE. So when we talk about differential equations, one thing we want to talk about is order of the differential equation. The order is the highest derivative that we're going to see. So in this example, this differential equation we would say is an order of 1 differential equation because the highest derivative we see is a 1. In this set, that first one has an order of 1. That second one, we see a third derivative here, so we would say this is an order 3 differential equation. And in that last one, we would say this is an order 4 differential equation. So let's say we want to find a particular solution. When we talk about differential equations, we could talk about a general solution versus a particular solution. General solutions is really what we've been doing since the end of Calc 1. Anytime we integrate, we're going to have that plus c on the end. Remember, that creates a family of functions that's shifted up and down on the Cartesian plane. That's what plus c does, is it shifts things up and down. So the general solution would always have a plus c. The particular solution will have enough information to find what c is. So let's look at this example. We want to find a particular solution to the differential equation y prime equals 2x, and it's going to pass through the point 2, 7. We started solving things like this back in Calc 1. We could rewrite y prime as dy over dx. And then we did something called separation of variables, and we'll get more into that a little later in this chapter about differential equations. But we want to get all the y stuff on one side and all of the x stuff on the other side. And now we're in a form where we can integrate. When I integrate the left, I'm going to get y. When I integrate the right, I'm going to get x squared plus c. So, side note here, when we integrate y, it's really a y plus c, right? I'll call that constant c1. And when I integrate that other side, 2x becomes 2x squared over 2, which is x squared plus a constant. I'll call it c2. So we could move the constants to the other side. And if I have a constant minus a constant, it's still a constant. I don't know what it is, so I can just call it C. So it's really not necessary to put the C on both sides because you can always combine them by adding or subtracting them. So now the question becomes, what is C? We want to go through this point. So we're going to substitute in what we know. We know when x is 2, y is 7. So 7 equals 2 squared plus c. And we can see that c is going to be equal to 3. So we're looking at the equation x squared plus 3. So let's go to Desmos so we can see what's going on here. So I'm in Desmos. I graphed the x squared plus c, so you can see that's quadratic and it's shifted up or down depending on what c is. I can move my slider to see that. I want the particular solution that's going to go through the point 2, 7. So I want to know what would c have to be. So I could play with the slider. This one ends up being a nice number 3. So when I graph this y equals x squared plus 3, it goes exactly through that point. Now we can't always use the slider. What if we didn't have a nice point here? What if it were something like with fractions in it or irrational numbers? Then that C value gets a little bit more complicated. But for this one, that's a really nice example of what's going on. Let's look at the next one. We want to verify that the function y equals 2e to the negative 2t plus e to the. So let's look at example 4. We want to verify that the function y equals 2e to the negative t plus e to the t is a solution of the initial value problem y prime plus 2y equals 3e to the t, where y of 0 equals 3. So there's the initial value they're talking about. And the point here would have an x coordinate of 0 and a y coordinate of 3. So they're talking about through the point 0, 3. Now, we'll talk about how to find this solution later. This is something called a first order, because of that first derivative there, linear type of differential equation. And there's a way to solve that, which we'll talk about later. But right now, we just want to verify. So it's going to work the same way it did before. They've just given us a little bit more information. That information has already been applied to this. Notice we do not have a plus c there. So let's find that y prime. To take the derivative of 2e to the u, it's 2e to the u times du. And the derivative of e to the t is just e to the t. So my derivative of y is negative 4e to the negative 2t plus e to the t. And we're going to substitute everything in. So I have y prime plus 2 times y. My y is 2e to the negative 2t plus e to the t. I want to know, is that equal to 3e to the t? So I'm putting in, again, a question mark over that equals. We're going to do some fancy math. Distribute. You can see how those e to the 2t's go out. They cancel. And so we're going to have 3e to the t, and that is equal to 3e to the t. So we have verified this is a solution to the differential equation. So let's look at another example. Let's say we want to solve this initial value problem. We've got y prime equals 3e to the x plus x squared minus 4, and they're giving us the initial condition y of 0 is equal to 5, which means when x is equal to 0, y is equal to 5. So we have dy over dx is equal to 3e to the x plus x squared minus 4. We're going to separate the variables. So multiply both sides by dx. And now we're in a form where we can integrate. When I integrate dy, I get y. The right-hand side is going to be 3e to the x plus x cubed over 3 minus 4x plus c. So there's my general solution. To find the particular solution, we're going to substitute in that initial value, 0, 5. So y is 0. Sorry, y is 5 when x is 0. So we're going to get 5 equals 3 plus c. So that means 2 is equal to c. So my particular solution, I'm trying to get that to scroll. Particular solution, y equals 3e to the x plus x cubed over 3 minus 4x plus 2. So there's the basics of differential equations. What is a differential equation? What's the difference between a particular and general solution? And just solving some really basic separation of variables types problems. So in the next video, we're going to dive into differential equations a little bit deeper.